Welcome back, guys. We are in 6.3 today talking about box and whisker plots. So to deal with a box and whisker plot, we need to remember a lot of our important vocabulary here. So we first start by taking our data and putting it in order, and then we want to separate into quartiles. Now, these quartiles are going to allow us to actually create that box and whisker plot that we're so used to. So we start by finding our median. Our median is also called the second quartile. So our median, again, is always that middle data point. If we don't have a single middle data point, we take the mean or the average of the two middle data points. So that's going to separate us into an upper half and a lower half. Of the upper half and the lower half, we go ahead and find our quartiles 3 and quartiles 1, that those are going to be the median of the upper and the lower. So my median of the lower is 5 and my median of the upper is 21. Then we find the interquartile range as the range between quartile 1 and quartile 3, so we just find the difference. So here it would be 21, subtract away the 5, and we would get an interquartile range of 16. Work through problem 1 until you get to the got it, and then try it on your own. If you get stuck, come back to the video. Otherwise, don't come back until you want to check your answer. Alright, so for number A, I'm going to help you and show you how we go ahead and find the minimum, first quartile, median, third quartile, and maximum. So the order in which they ask us these, I kind of don't really like. So let's go ahead and find your minimum and your maximum. Now hopefully I don't need to make these two different colors. Your minimum is 60. Your maximum is 105. That was not too hard. So now, one thing we need to do is count how many data points we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. So the middle term of that would be 6. So 1, 2, 3, 4, 5, then the 85. I would also have 5 on the right side of it. That makes this 85 my median. Now that we found our median, we now have a lower half and an upper half. So my lower half has 5 terms in it. So to find quartile 1, I go to the median of that half, which is now 75. To find my upper half, quartile 3, I find that median, which is 95. So now I've got my quartile 1 and my quartile 3, my minimum, my maximum, and my median. Go ahead and do that for B if you have yet to do so, and come back just for the answer. So here's your answers for A listed out, and your answers for B, having my minimum, my quartile 1, my median, my quartile 3, and my maximum. Do the same work for these two data sets and come back just to check your answer. Alright, so for both of these, remember we're going to have it in the order of minimum, first quartile, median, which is also quartile 2, then quartile 3, and the maximum. So there are your answers for 1 and 2. So now we're going to talk about your box and whisker plot, which is a good way to represent your data because it lets you see your dispersion. Each of these sections is 25% of your data. So you know that 25% falls between the minimum and quartile 1, 25% of it falls here in between quartile 1 and 2, 25% between quartile 2 and 3, and then 25% between that and the maximum. You can see here we have quartiles 1 and 3 making up the edges of the box. Our median is a vertical line through not necessarily the middle of the box, but through the middle point. So you always set it up relative to a number line. So sizing of this does matter. So go ahead and create a box and whisker plot to represent this data set. Now you're going to want to start by writing out the data in order and then finding all those points, the min, max, quartile 1 and 3, and the median. So when we begin this problem, we list out everything in order from least to greatest. So there I am in order, but now we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, verify that that matches the number of terms we have up here. But 10 being an even number tells me that to find my median is going to be a little bit more difficult. So now I count 1, 2, 3, 4 off the left side, 1, 2, 3, 4 off the right side, and I'm left with just 14 and 15. So my median is actually going to be between those two at 14 and a half. Now that my quartile 2 or my median is not one of these points included in the upper or lower halves, I still have 5 points in the lower half, which makes my quartile 1 the 9, and quartile 3 becomes the 16 here. My minimum and my maximums are 4 and 34. So now I have everything needed to find or to complete my box and whisker plot. So if I clear this way, here you see we've got my minimum at 4 my maximum at 34, my quartile 1 is at 9, my quartile 3 is at 16, and then my median is very close to quartile 3, it's at 14 and a half. Create the box and whisker plots for 3 and 4. I'm not going to walk you through how to do it anymore. I'm just going to show you the answer, so come back just to verify your work. For number 3, your box and whisker plot should look something very similar, if I can get my controls back. There we go, something very similar to this, with your median just below 500, your quartile 1 just below 400, quartile 3 right around 575, under 600, and then 4 should have a box and whisker that looks very similar to that. Make sure you've worked through Pearson to make it to this got it. We want to look at the box and whisker plot here from problem 3 and compare the medians of Miami and New Orleans dealing with their average monthly rainfall. So remember, my medians are right here and right here. So I see as the median amount of rainfall in Miami is less, New Orleans is higher, but pay attention to the range that happens in Miami compared to New Orleans. What the median conveniently does is splits my data in half, so I could say for half the year I have less than 4.5 inches in Miami, and for half the year I have greater. Same thing with New Orleans. I could say for half the year I have less than about 5.3. I mean, we could easily say 5.5, and then greater than around that 5.3 for the other half of the year. So write out a statement of what you think the box and whisker plot here shows us about the fuel efficiency of cars compared to trucks. The biggest difference I see here between cars and trucks is the range. My minimum to maximum in cars is from about 14.5 to 50, whereas in trucks it's only from about 18 to 22. So man, that range is a whole lot smaller when I'm looking at purchasing a truck. We can also say something about how the majority of cars, 75% of our cars, are higher than the third quartile of trucks, which means that 75% of trucks are in this very low range, lower. They're only there with only about maybe 10% of all cars if we try to approximate how where that would be the same. So here is an example of my statement. Of course, your statement's going to be unique to yours and dependent on what you focus on. Alright, so now we're going to discuss percentiles. So percentiles separate data into 100 equal parts, which makes sense because we have 100% as a total. And when we talk about percentile rank, we're talking about the amount of values that are less than or equal to that given value. Go ahead and work through problem 4 in the Pearson module, and do not come back until you've tried the got it on your own. So pause the video until you think you have your answers for the got it, come back to check. So again, to find the percentile rank, we take how many are less than or equal and divide by the total. So we set up this math right here for A, and that gives me 6/10, which we can simplify into 60%. So that score would have a 60% ranking. And then talking about, is it possible to have a percentile rank of 0? Well, when we talk about a percentile rank of 0, that would mean that there are 0 scores less than or equal. But you can never have no scores equal to your score because you are that score equal to it. So there for B, we would say no, because there's always at least the score equal. Try number 6 and 7 on your own. I will come back to quickly explain them, but pause the video now. Don't come back till you have your answers. So for number 6, we say that of 10 test scores, 6 are less than or equal. So the math we set up is 6 over 10, which gives me 60%. And then in 7, of 35, we see that 28 are less than or equal to the score we're looking at. So we set up 28 over 35 and find out that that is 80%. Alright, these are the last problems from today's lesson. Try 8, 9, and 10 on your own and then come back to verify your answers. Alright, so once we put things in order and then find my quartiles, my medians, my mins, my max, we see all of this. So quartile or minimum, maximum, quartile 1, quartile 2, and quartile 3. And for number 9, dealing with our daily attendance, we have our min and our max, then quartile 1. Quartile 2 came from averaging 2 values, and so did quartile 3, actually. Actually, quartile 1 did also, so all of these quartiles came from averaging values. And then in 10, we're looking at which has the greater interquartile range. You're looking at which box spans the furthest. Should have been fairly easy. It is class B. that is all I have for you guys on Box and Whisker Plots. So please make sure it all makes sense. Let me know if it does not, and I will see you guys in class. Thank you very much and have a wonderful day.